Assalamu alaikum. This is the second class of vectors of P3. Okay, today we're going to learn about intersecting lines. Okay, in two dimension, if there are two lines, there is a possibility that they may be intersecting or they may not be intersecting. There's no third possibility. They are either intersecting. If they are not intersecting lines, then they are not intersecting lines. So not intersecting meaning that means they are parallel. But in 3D, that means in three dimensions, if you talk about three different vectors, either they are intersecting or they are not intersecting. Even if they are not intersecting, it's not necessary that they are parallel. Sometimes the lines are not intersecting in 3D, but still they are not going in the same direction. Okay, so let's see how do we find whether the lines are intersecting parallel or no. You just have to see the direction vector of the line. Okay, these are the two lines. This is the equation of a line and this is the equation of another line here. Now if you look at this in the vector form, okay, now this is the direction vector of the line and this is also the direction vector of the line. If you just observe the direction vector of the line, have you multiplied this whole vector, the direction vector of this line, by any number to get this? 1 multiplied by 2 is 2, but 2 multiplied by 2 is 4. If there is a 4 here and if there is a 6 here, that means we can say that the two lines are parallel to each other because the direction vectors are the same. Okay, if you look at this one, if this is 6, negative 9 and negative 3, okay, and here it is 2, negative 3 and negative 1. Negative 1 multiplied by 3 is negative 3, negative 3 multiplied by 3 is negative 9, and 2 multiplied by negative 2 multiplied by 3 is a 6. Okay, so we can say that yes, these two lines are parallel. The reason being the direction vector, they are going in the same direction. How do we know whether they are going in the same direction? Just observe and see if you can take out anything as common, and after you take out common, if the inside thing becomes the same, like if I take out 3 as common from here, I'll be left with 2, negative 3 and negative 1, which is the same as this. So we say that yes, the two lines are parallel to each other. Okay, now if the lines are not parallel, then we have to learn how to find out the point of intersection of the line. Okay, let's go about finding this out. Find the position vector of the point where the two lines intersect. Okay, so this is the first equation, this is the second one. Note here are different letters are used for the parameters and the two equations to avoid confusion. Okay, here they have used lambda and here they have used mu. Okay, how do we go about solving it and finding out the line point of intersection? Okay, if we can just equate, if I take it from the first line, 2 plus lambda and 6 plus mu. Okay, so 2 plus lambda equals to 6 plus mu. Then it's 3 plus 2 lambda equals to 1 minus 3 mu. Simultaneously solve the two and get the value of lambda and mu. Okay, so I'm making lambda the subject from the first equation. So from equation number 1, lambda equals to 6 minus 2 is 4 plus mu. Putting it in the second equation, 3 plus 2, 4 plus mu equals to 1 minus 3 mu. Okay, 3 plus 8 plus 2 mu equals to 1 minus 3 mu. 5 mu equals to 1 minus 11. 5 mu equals to minus 10 and mu equals to minus 2. Okay, lambda is 4 plus mu. 4 minus 2, which is a 2. Okay, once I get the value of lambda and mu, I can either substitute lambda in this or mu in this to get the point of intersection. Okay, substituting lambda in 2 plus lambda and 3 plus 2 lambda, I will get 2 plus 2 or 3 plus 2 times 2, which is actually 4 and 7. Okay, this is the point of intersection. Even if you put it, if the value of mu into this, okay, into this, then also you're going to get the same point of intersection. Okay, let's move on. Find the coordinates of the point of intersection of the two lines joining 1 6 and 4 0, and C, which is 1 1 and 2 5 3. Okay, if you would do it in the coordinate geometry, you would find out the equation of this line and the equation of this line and solve them simultaneously to get the point of intersection. But if you want to use the vector method, in that case I'm going to make the equation of this vector and the equation of the line of this vector, the vector equation of this line, and then I'm going to solve them simultaneously to get the point of intersection. Okay, so if I call this as line number 1 and if I call this as line number 2, okay, so if I say the vector equation of a line would be point on the line is 1 6 plus lambda times the direction vector of this line. If I take the direction vector of this line, AB is OB minus OA. Okay, OB in terms of this is actually the coordinate. Okay, if you write it in the form of column vector, you would write it as 4 0 minus OA, which is 1 6. So it's 3 and minus 6. Okay, and L2, I'm taking the point C and the direction vector of CD, which is OD minus OC. Okay, OD is 5 3 minus OC is 1 1 4 2. Okay, now I have to solve it. So 1 plus 3 lambda equals to 1 plus 4 mu, and 6 minus 6 lambda equals to 1 plus 2 mu. Okay, if I multiply, or if I make lambda the subject from the first one, it will be 3 lambda equals to 4 mu. Lambda equals to 4. Okay, 6 minus 6 4 upon 3 mu equals to 1 plus 2 mu. 6 minus 8 mu equals to 1 plus 2 mu. 10 mu equals to 5. Mu equals to 5 upon 10. Okay, once we get the value of mu as 5 upon 10, we can substitute it in any one of the two equations. I'm taking, since I have the value of mu, I will substitute it in this equation. Okay, so L2, 1 plus 4 mu, 1 plus 2 mu. Okay, 1 plus 4 times 5 upon 10, 1 plus 2 times 5 upon, you can simplify 5 upon 10 as 1 upon 2. This is the point of intersection of the two, 3 comma 2. Okay. But this question which we have done was in 2 dimension. Even the previous one which we have done was in 2 dimension. Okay. Let's move on. Determine whether either each pair of lines are parallel, intersecting, or skewed. Okay. If I do the first one, okay, 1 minus 3 lambda minus 2 plus 2 lambda and 1 plus lambda equals to 1 plus 6. This is in 3 dimensions. Okay, so what you should do is take the first two, get the value of lambda and mu, okay, and then go ahead with it. First of all, you just have to take the first, because this is in 3 dimensions, you'll make 3 equations with this. Firstly with these two, and then once you get the value of lambda and mu, you put it in this one, and I'll tell you how to go about doing it. Okay, let's do this one first. 1 minus 3 lambda equals to 1 plus 6 mu, and minus 2 plus 2 lambda equals to 3 minus 4 mu. Okay, if I make lambda the subject from the first one, plugging it into the second equation. Minus 2 minus 4 mu equals to 3 minus 4 mu. This is getting cancelled, and you have anything left here in terms of the variable. If you notice here, so the two lines are parallel because you will not be able to find out the point of intersection. If you notice the position vector, even if you don't start solving it, what you can observe here is just look at the position vector. If you multiply this by 2, you get a 6. By a negative 2, you get a 6. When you multiply this by a negative 2, you're getting a minus 4. And when you multiply this by a negative, you're getting this. So just observe the direction vectors and you can say that the two lines are parallel. As far as this is concerned, let's see the second one. So if the lines are parallel, then what will happen? You will not be able to find out the value of lambda or mu. Okay, from the first equation you can write 1 plus 2 lambda equals to 4 minus mu. 2 minus 3 lambda. Acha, first you observe the direction vectors. Okay, if you multiply this by negative 2, you're getting a 2. So when you multiply this by a negative 2, you should get a negative 4, but it's a negative 3 here. That means not the direction vector, because of the direction vectors, if you observe them, they are not parallel. That means even if you take out something as common, the inside thing will not be the same. Okay, 2 minus 3 lambda equals to negative 2 plus 2 mu. Negative 1 plus 4 lambda equals to negative 5 plus mu. Okay, if I take the first two equations first only, and then I'll tell you how to go about doing it. I'm making mu the subject from the first one. So mu equals to 4 minus 1 is 3 minus 2 lambda. Okay, substitute mu in the second equation. So 2 minus, substituting in equation number 2. 2 minus 3 lambda equals to minus 2 plus 2 times mu, which is 3 minus 2 lambda. 2 minus 3 lambda equals to minus 2 plus 6 minus 4 lambda. Okay, 4 lambda minus 3 lambda is mu lambda. 4 minus 2 is 2. Okay, so mu is 3 minus 2 times lambda, which is 3 minus 2 times 2. 3 minus 4 is a minus 1. So we have lambda as 2 and mu as minus 1. Now, how to find whether we know for sure the lines are not parallel. Okay, so how do we find out whether the lines are intersecting or they are skewed? Intersecting, in case of intersecting, we'll get a point of intersection, and in case of skewed, we will not get a point of intersection. Okay, now what I'm going to do is I'm going to substitute the value of lambda into this. 1 plus 2 lambda. Okay, 2 minus 3 lambda and minus 1 plus 4 lambda. Okay, I'm getting 1 plus 2 times 2, lambda is 2, so 5 here. 2 minus 3 times 2 and minus 1 plus 4 times 2. So I'm getting a 5. 2 minus 6 is a minus 4, and minus 1 plus 6 is a 5. I'm getting this point. Okay, let's substitute it in the second equation also. Second equation. So 4 minus mu minus 2 plus 2 mu and minus 5 plus mu. Okay, let's see. The value of mu is negative 1. So 4 minus minus 1. Minus 2 plus 2 times minus 1. And minus 5 plus minus 5 minus 1. Okay, I'm getting 5 minus 2 is a minus 4. And minus 5 minus 1 is a minus 6. Okay, if you notice here, the point of intersection is 5 minus 4 and 5, and here the point of intersection is 5 minus 4 and minus 6. That means if you're not getting the same points, that means the two lines are skewed. Okay, if you get the same point of intersection, okay, then you would say that the lines are the lines are intersecting. Okay, so you can say the two lines are skewed. Okay, let's do another question.